Hello everyone. In today's video, we are looking at word problems from divisibility rules of number system. The basic concepts have already been covered in my previous two videos, whose link is given in the description below. The problems solved here are questions asked in the previous years of Staff Selection Commission and bank exams. The first question is this. If a 9-digit number 83P93678Q is divisible by 72, then what is the value of square root of P square plus Q square plus 12? These are the four options given. The given number is said to be divisible by 72. So in problems of this kind, the first step is to write 72 as product of two co-primes. Co-primes means numbers with no common factors. As you can see, 8 and 9 have no common factor. That is the first step. Since this number is given to be divisible by 72, it is divisible by both 8 and 9. So let's first use the idea of this number being divisible by 8. And what is the test of divisibility of a number by 8? A number is divisible by 8 if the last three digits of the given number is divisible by 8. Here actually we're not making use of the divisibility rule to verify whether a number is divisible by 8. Here it is given that this 9-digit number is divisible by 8, which implies the number formed by the last three digits of the number, that is 78Q, will be divisible by 8. So what are the possible values of Q? Being a single digit number, it ranges from 0 to 9. So let me use the smallest possible value. You get 780. Then divide that number by 8. You get 72. I'm not writing the quotient just to save a little time. Remainder is 6. You bring down this 0 and write here. As you know, 8 does not divide 60. But we know that 8 divides 64. Which means if you write 4 here, for which this number, if you make 4, you will be getting 784. I'm just showing how to identify the missing number Q here fast enough. Now, if you put 4, you will be getting 4, and 64 is a multiple of 4. Rather, 784 is divisible by 8, which shows the first value of Q is 4. And what would be the next value? See, you don't need to waste time looking at the next value, because if 784 is divisible by 8, the next number that is divisible by 8 will be the number got by adding 8 to this number. And what is the number you get by adding 8 to this? 792. See, you can't change this number 8. When you add 8 to this number to get the next number divisible by 8, it becomes 792. So this is not possible. So there's only one value you can find out for Q, and that's 4. So the number will reduce to 83P3678. Now in the next step, we need to identify the value of P, for which we will use the idea of this number being divisible by 9. And in the test of divisibility by 9, the basic rule is to take the sum of the digits of the number, but there is a shortcut which I have already shown in my previous video. So what we do is to remove multiples of 9 first. There is 9 here. You can straight away cancel that. Then what do? These two digits, 3 and 6, their sum is 9. So you can strike out these two. Then look at the other numbers. 8 plus 3, 11. 11 plus 7, which is 18. And that's a multiple of 9. So you can remove these three. Then you are left with 8, 4 and P. Obviously 8 plus 4 is 12, which is not a multiple of 9. So you keep it as it is here. And these three remaining numbers, which are P, 8, 4, you just add. You get 12 plus P. So as per the rule of divisibility, this 12 plus P is to be a multiple of 9. And what is the value of P so that 12 plus P is a multiple of 9? See, if 12 plus P equals 18. 18 is the number just above 12, which is a multiple of 9. So P has to be 6. So we got one value of P. Theoretically speaking, you can find out other values of P. if 12 plus P is equal to say 27, 27 also is a multiple of 9, but this shows P will be 15. But we know that P is a single digit number, which means this is not acceptable. What I'm trying to convey is there is only one value for P, and that is 6. And also we have already seen the value of Q as 4. So P equals 6 and Q equals 4. The problem is about finding the value of this algebraic expression. Let me write that again. The required expression to be evaluated. P square plus Q square plus 12 equals 6 square plus 4 square plus 12. This is 36, this is 16, 36 plus 16, 52, 52 plus 12, 64, which is 8. That is the third option in the problem. The second question is this. If a 9-digit number 468x 5138y is divisible by 72, then the value of square root of 4x plus 3y equals what? These are the four options given. Like we did before, factorize 70 into two co-primes. So the given 9-digit number is divisible by 8 and 9. We will first use the idea of this number being divisible by 8. And what is a test of divisibility by 8? The last three digits, that is 3, 8, y, is divisible by 8. As you know, y ranges from 0 to 9. So let me use the smallest value for y, which is 0. You get 380. Just divide it by 8 and see whether this number is divisible by 8. You get 32, 6, 60. As you know, 60 is not divisible by 8. And what is the number you should get here instead of 0? If you put 4, you know that 64 is divisible by 8. That implies 384 is divisible by 8, which shows y equals 4. And this is the only value for y. So the given 9-digit number may be written as 468x 51384. I'm using 4 instead of y. This is the next digit x to be found out, for which we use the idea of this number being divisible by 9. In the test of divisibility of 9, like I showed you before, we will combine numbers like this, 8 and 1. That is 9. You can cancel it. 6 and 3 together, 9. That also you can cancel. And then you have 5 and 4, which is 9. You cancel. And you're left with 4x and 8. Take the sum of these three numbers. 4 plus x plus 8, which is 12 plus x. And for this number to be divisible by 9, the value of x is 6. Because 12 plus 6 is 18, which is divisible by 9. So we got the value of x also. So x is equal to 6, y is equal to 4. And this is the expression to be evaluated. So square root of 4x plus 3y equals square root of 4 multiplied by 6 plus 3 multiplied by 4. This on simplifying you get 36, which is 6. And that is the third option. The third question is this. If a 7-digit number 678P37Q is divisible by 75 and P is not composite, then P plus Q is what? These are the four options given. Like I said before, in all problems of this kind, this number 75 we will write as product of two co-primes. Co-primes, as I said before, are numbers with no common factor. You can see there is no common factor. Since this number 678 P37Q is divisible by 75, this number is divisible by both 3 and 25. Let's use the idea of this number being divisible by 25. For a number to be divisible by 25, the last two digits should be 0, 0, 25, 50, 75. See, the given number is, there is 7 as the last but one digit here. So the last two digits should be 75. You can't have these possibilities. And this shows Q equals 5. So this number you can write now 678P375. I'm writing 5 in terms of Q. Now we need to identify the value of P here, for which we use the idea of this number being divisible by 3. In my previous video, I've shown you the divisibility rule of 3. The shortcut is this. Cancel the digits of this number, which are multiples of 3. Straight away you can remove 3 and 6 also. The other numbers are not individually divisible, but you can combine like this. See, if you sum these two, 7 and 5, you get 12, which is a multiple of 3. So these two removed. Then you have again 7 and 8, which is 15. So that also you can remove. You are left with P. So P has to be a multiple of 3 as per the test of divisibility by 3, for which either 0, 3, 6, 9. These are the 4 possible values for P. It is given that P is not composite in the problem. So you can remove these two. 6 is a composite number, 9 is a composite number, and 0 also we don't count. See, if a number is not composite, it should be prime. And 3 is the only prime number here, which shows P is equal to 3. Thus, we got the values of both P and Q. And the question is about finding P plus Q, which is P is 3, Q is 5, and the answer is 8, which is the last option given in the problem. We will continue with the divisibility rules. We have not considered the divisibility of a number by 11 and 5, which I will do in my next video. So please subscribe to my channel and hit the bell icon so as not to miss out my next video. If you found this video useful, please like and share it with others. Thanks for watching and see you in the next video.